All right, so this is the fourth solving equations, second lesson of the current unit. We are going to finish this up with 3 word problem lessons. So here we go. These are absolute value equations. So what I want you to see in the learning target is I can set up both equations to find the solutions to an absolute value equation. That's huge. A lot of people don't remember that there are 2 answers when we have these equations. So I'm going to get to why there are 2 equations now. So first of all, a reminder of what absolute value is. An absolute value is a number's distance from 0. So an absolute value equation is an equation that has a variable inside the absolute value bars. Okay, so something like this, that's not an absolute value equation. Because look at where the variable's at, outside. The answer to this question is just 5. Okay, but if you look at the next one, this is an absolute value equation because the variable's inside the absolute value. So this is what you should say to yourself when you see these types of problems. The absolute value of what numbers equal 5? Or, another way of saying that a little quicker, which numbers are 5 units away from 0? Well, if I ask it that way, most of you can probably give me those 2 numbers real easily. Okay? One thing I want you to see up here, I put the S in bold to emphasize that typically absolute value equations have 2 solutions, kind of what I was talking about up here. This is because there are 2 numbers that are, in this case, 5 units away from 0. -5 and +5. So this one has 2 solutions. They're solutions because when I put them in, it makes a true statement. The absolute value of -5 is 5, which is true. The absolute value of 5 is also 5. Okay? Now, that's great. This is simple, right? You're thinking, oh, this is really easy. However, the expression inside the absolute value bars is usually more complicated than just x. Here's an example. Not much more complicated in this case, but a little bit more complicated. Okay, so here's how I would think of these, especially here at the beginning. I'm going to cover that up. We know that the 2 numbers that are 18 units away from 0 are -18 and +18, right? 2 numbers whose absolute value are going to be 18 are -18 and +18. Therefore, we need to find out what x values will get the expression inside the absolute value bars equal to those numbers. Okay? To do that, we write 2 equations. Okay? And what you're going to do is you're going to write whatever expression is inside the absolute value bars. So in this case, it's just 3x. So 3x equals and 3x equals. Those are nothing changes inside the absolute value bar. Okay? But then you have to figure out, okay, 3x equals, what's going to make it equal to -18? And what's going to make it equal to +18? And the reason we want that is, what x value is going to give me -18? Well, why do I care? Because if I get an x value that makes -18, then the absolute value of -18 would make this a true statement. So we can solve those pretty quickly. Divide by 3. In this case, x equals -6 for the first one and +6 for the second one. Okay, another example here. So whatever's inside the absolute value, nothing changes there. So it's x minus 4, x minus 4. What I'll see a lot of people do is say x minus 4 and x plus 4. Nothing changes with the expression inside the absolute value. What changes is what it's equal to. We want to know what 2 numbers are 7 units away from 0. Well, that would be -7 and +7. Okay? So what I'm going to do is I'm going to add 4, so -7 plus 4 would be -3. And then I'll do the second one. Now, a lot of people look at this and see the first two questions are just one, -5, +5, -6, +6, they'll think -3, this has got to be +3, because it's what it's been so far. Not always. Watch what happens here. Oops, that was 7. I was ahead of myself there. X is 11, right? So these two numbers are going to give me 7 and -7 inside their absolute value, which is what we want. -3 minus 4 is -7. The absolute value of -7 is 7. 11 minus 4 is 7. Absolute value of 7 is still 7. A couple more examples, and they get a little bit harder. So we want to solve this thing. What I want you to see is that this one has a number outside the absolute value bars. Before we write our two equations, we need to isolate not the variable, but the absolute value expression. In this case, we need to divide both sides by 2. Okay, so we're going to divide both sides by 2 here. Okay? One thing I want you to make sure you do not do. A lot of people look at that and think, oh, it's like a parentheses, I'm going to distribute. You cannot distribute here. You cannot distribute the 2. If you do, it will be wrong. Okay? So, our new equation after dividing by 2 is the absolute value of x plus 7 equals 18 divided by 2, 9. Now the absolute value expression is isolated. There are no numbers outside the absolute value bars on the left side. Now we can write our two equations. So equation 1, x plus 7 equals, x plus 7 equals, notice how I do that? I'm not going to change anything inside the absolute value. So just write it down as it is. What changes is what it's equal to. So -9 and +9. Subtract 7. -9 minus 7 is -16. 9 minus 7 is 2. My two solutions. Okay, so we're going to practice. I'm actually not going to leave anything blank in this notes. But if you think you got it and you're feeling pretty good about it, pause it, try this one, and then watch it and see if you get it right. Okay, so I need to move the 4 and the 1. Okay, and I do this just like I would solve this problem here. So imagine I had 4x plus 1 equals 13. What I do is I subtract 1, right? So I'd have 4x equals 12, and I divide by 4. And I get x equals 3. But instead of it just being x, now I got this whole expression. But I'm still doing the same process. I'm subtracting 1 first. And then I'm going to divide by 4. So now I have the absolute value of 2x minus 5 equals 3. So now I can make my two equations. And you'll see me do that a lot. The two little, like I'm making a tree almost. 2x minus 5 equals 3. And 2x minus 5 equals -3. Add 5, I get 2x equals 8. Divide by 2, x equals 4. So there's one solution. Add 5, I get 2x equals -3 plus 5 is 2. Divide by 2, I get x equals 1. My two solutions. Okay? Again, if you feel good, pause it and try this one. If not, keep watching. A lot of people on this one, common mistake, they'll say 10 minus 3 makes 7. You can't do that. Okay, this is -3 times this absolute value. So what I need to do is I need to move 10 first, and I'm left with -3 equals -6. And then I'm going to divide by -3, and I'm going to get 1 minus x equals 2. And now I'm going to make two equations. 1 minus x equals -2. 1 minus x equals +2. A little bit trickier to solve this one. Not much, hopefully. That's a -x equals -2 minus 1 is -3. Divide by -1, and you get x equals 3. Over here, I get -x equals 1. Divide by -1, I get x equals -1. Okay? And there we go. Got my two solutions. Last bit here. Special case. Solve that expression. This equation, sorry. When you isolate the absolute value expression, you get, so let's go ahead and do that. I'm going to subtract 13, just like we've been doing. So I'm going to get 2 absolute value of x plus 8 equals negative 8. Divide by 2, and I get absolute value of x plus 8 equals negative 4. Many people are just going to automatically move on to making your two equations. But think back to what I had you say at the beginning. Which numbers are negative 4 units away from 0? When you ask that question, you should think, wait a second, that doesn't make any sense. This situation is impossible. You can't be negative 4 units away from 0, because distances are always positive. Okay? Therefore, this equation has no solutions. It is not possible to be negative 4 units away from 0, because all distances are measured in positive numbers. So, a lot of people are going to look at these and say something like this. I'll say negative 2 absolute value of x plus 1 equals negative 8. And they'll say, oh, look, it's equal to a negative. No solutions. Super easy. But that's not true. Before you can say no solutions, you must isolate the absolute value expression first. So I would have to do one step before I say anything, and that would be divide by negative 2, and watch what happens. Absolute value of x plus 1, a negative divided by negative becomes a positive, and now you can actually solve that equation. Okay? Example here at the bottom. This is what I was talking about. A lot of people are going to look at that and say no solutions. And then they'll subtract 6. 3 plus n equals negative 1 minus 6 is negative 7. And now you would say no solutions, right? Wrong. What did I forget to bring down? I forgot to drop down that negative. Now I got to divide everything by negative 1. So now I have 3 plus n equals positive 7, and I can actually solve this one. So 3 plus n equals negative 7. 3 plus n equals 7. Subtract 3, you get n equals negative 10. Subtract 3, you get n equals 4. And that is absolute value equations.